Key performance indicators, KPIs, play a crucial role in assessing and comparing the capabilities of different blockchain platforms. In the fast-evolving world of blockchain technology, differentiation and superior performance are key to attracting developers and users. Key indicators. Key performance indicators used to measure the performance of a blockchain network include 1. Transactions per second, TPS. TPS is one of the critical indicators studied by anyone familiar with the blockchain industry, which refers to the number of transactions a blockchain can process in 1 second. TPS is used to identify the scalability of a blockchain and the amount of data it can process. The number of transactions submitted to the blockchain and the number of transactions stored in the ledger can be measured separately to obtain higher clarity and better results. However, blockchain with high TPS value is not necessarily superior to other available options, and many other factors should be considered. For example, the TPS value of BTC is very low, but there are thousands of nodes at any time, which makes BTC one of the most popular blockchains. 2. Transaction latency. Transaction latency refers to the time between the submission of a specific transaction to the block and its approval or rejection. Once a transaction is approved, we can see and use it throughout the entire blockchain. This key indicator is helpful to compare the ability of blockchain to react quickly to transactions, which is a key aspect in any sense. 3. Transaction throughput. Transaction throughput is the time required to add an effective record to the block. The corresponding time is calculated only after the relevant record has been approved. Other time is not taken into account. To calculate transaction throughput, simply divide the total number of records added to the block by the total time in seconds. 4. Energy efficiency. Although energy efficiency is not a direct network performance indicator, it plays a crucial role, considering the global energy shortage and the increasing consensus on saving energy worldwide. Blockchain needs a certain amount of energy to play its role, mainly for transaction validation, processing, and storage. The energy consumed here largely depends on the consensus mechanism adopted. Although most major blockchains use the POW, proof of work, model, which is a high energy consuming model, various new blockchains rely on more advanced and low energy consuming POS, proof of stake, or POA, proof of authority, mechanisms. Therefore, before selecting the next blockchain development project, please make sure to check which consensus mechanism is used. 5. Number of verifiers. Validators refer to individuals who validate transactions on the blockchain in exchange for rewards. They are typically specialized in the blockchain and work to maintain its integrity. Once a transaction has been validated, it is added to the blockchain ledger. Whenever a transaction is initiated on the blockchain, validators add it to a block for validation. Once a block is completed, it is stored on the blockchain and cannot be modified. All of these tasks are performed by validators. Therefore, the more validators there are, the better the performance of the blockchain. 6. Block time. Block time is the amount of time required for validators or miners to validate the transactions stored in the block. Once completed, another transaction is created. The total time required for these steps is block time. In addition, miners or validators who participate can receive rewards. The Transformers blockchain is engineered to offer a suite of advantages in blockchain performance, leveraging the lessons learned from its predecessors like Bitcoin, Ethereum, Cardano, Avalanche, Polkadot, Cosmos, Flow, and Solana. Here are some of the performance strengths that set the Transformers blockchain apart. Security enhancements. The Transformers blockchain takes a cutting-edge approach to security, employing a hybrid consensus mechanism that combines the best aspects of proof-of-stake, POS, with additional layers of cryptographic security protocols. This unique combination not only ensures a highly secure network but also reduces the potential for the energy inefficiency found in proof-of-work, POW, systems like Bitcoin. With an eye towards future threats, Transformers also incorporates quantum-resistant encryption to safeguard against upcoming quantum computing capabilities. Optimized transaction speed and scalability. One of the defining advantages of the Transformers blockchain is its exceptional transaction throughput, handling tens of thousands of transactions per second (TPS), without compromising network stability. This is achieved through an innovative sharding solution that parallelizes transaction processing. Unlike Ethereum, which is transitioning to a sharding mechanism in its 2.0 upgrade, or Solana that requires specific hardware, Transformers is built from the ground up to support scalability on ordinary nodes, ensuring accessibility and continuous performance under high demand. Low transaction costs. Recognizing the barrier that high transaction fees can pose, Transformers is designed to offer consistently low fees. By optimizing the network structure and utilizing state-of-the-art data compression algorithms, costs are kept to a minimum. Transformers fees are a fraction of those on Ethereum, making it an attractive platform for developers and users, especially for frequent transactions and microtransaction-based applications. Thoughtful decentralization balance. While many blockchain platforms must juggle the trade-offs between speed, scalability, and decentralization, the Transformers blockchain employs a novel governance model that maintains a high degree of decentralization without compromising on performance. By leveraging a distributed system of nodes and a fair validator selection process, Transformers ensures that no single party has disproportionate control over the network, fostering a community-driven environment akin to Bitcoin and Ethereum but without their scalability issues. Eco-friendly design. In today's environmentally conscious society, Transformers positions itself as a green blockchain solution. By utilizing a post-consensus mechanism and energy-efficient protocols, it drastically reduces the carbon footprint associated with blockchain operations. This eco-friendly approach not only aligns with global sustainability goals but also offers an ethical incentive for eco-conscious developers and investors. Developer and user-friendly ecosystem. Through a robust and user-friendly interface, Transformers simplifies both the deployment of decentralized applications, dApps, and the minting of non-fungible tokens, NFTs. The platform's highly capable smart contract language, coupled with extensive documentation and developer tools, lowers the entry barrier, allowing a broader range of creators to innovate on the blockchain. Adaptive and future-proof network. Lastly, the Transformers blockchain is built with adaptability and future advancements in mind. Acknowledging the rapidly advancing tech landscape, Transformers offers a flexible framework that can easily incorporate new blockchain innovations, cryptographic methods, and potentially integrate with emerging technologies such as artificial intelligence, AI, and the Internet of Things, IoT. In conclusion, the Transformers blockchain is a thoughtfully constructed platform that aims to provide advantages across all key performance indicators. By focusing on security, speed, scalability, low costs, decentralization, eco-friendliness, and a forward-thinking design, Transformers is well positioned to become the blockchain of choice for projects requiring robust performance without compromise.